Now, what are gross substitutes and gross complements? Okay, so the two goods are gross substitutes. Okay, that is, suppose there are two goods xi and xj. Okay, and these are gross substitutes if del xi by del pj is greater than 0. Okay, so what do you mean by this? Suppose if xi is tea and xj is coffee. Okay, so if the price of coffee increases, the demand for tea also increases, because you will rather want to substitute into tea. Okay, because both of them are giving you equal utility. You will say, okay, now if the price of coffee is increased, so why will I demand more of coffee? I'll rather go into tea because that's also giving me equal utility as coffee. So del xi by del pj will be greater than 0. Now, in case of gross substitutes, okay, so in case of gross substitutes, del xi by del pj would be greater than 0. Now, suppose if there are again two goods xi and xj, and say pen and ink, these are two complementary goods. They have to be used together in order to give some utility, even though everyone is using gel pens now, so you don't need ink separately, but still, suppose if this is an example, and then you have your del xi by del pj would be say less than 0. Okay, now this would be the case of gross complements. That is, in case if the price of price of j is increasing, then the demand for I would also fall. That is, in case if price of ink would increase, then demand for pen would also fall, because you will say that, I mean, I'll be using pen only in case there is ink in it. And in case the price of ink is increasing, so the demand for pen would fall. And this happens very often in case of your automobile market, where when the price of petrol or fuel increases, then the demand for the product, demand for car, etc. would fall. Okay, so these are the gross complements. Now, the only problem with in the gross definitions is of asymmetry. Okay, so there is asymmetry of problem of asymmetry of definitions. Okay, in your gross terms. Okay, I'll give you an example. uh, Suppose if you have your utility function uxy is equal to, say, what, your x plus log y. Okay, now this is a quasi-linear kind of a function. Okay, this is a quasi-linear kind of a function. Now, if you find out the Marshallian demands for x and y, okay, which is not the topic of concern for this particular topic. I assume this in faith that you know how to find out x and y. Then now once you find out that x and y, and if you take the derivative, okay, of say, you find out two derivatives. One is del x by del py, and other is your del y by del px. Okay, these are the two. I mean, you just need to find out these two derivatives in order to conclude whether both of these are gross substitutes or both of these are gross complements. Okay, now when you do this, you find that del x by del py will come out to be 0, but del y by del px will come out to be greater than 0. Now you can definitely say this, that this is greater than 0, but for gross substitute definition to hold, this also should be greater than 0, which is not in this case. Okay, so you can't say precisely that whether they are substitutes or not. They would be, I mean, to some degree or what, but whether they are or not, you can't say. So this is the problem, and because of that, there is a concept of net substitutes and net complements. Okay, now that substitute your net substitutes and net complements. So that's a new concept which comes through because of asymmetry of gross definitions. Okay, so that is there. Now the reason is, the reason this problem is coming is because these gross definitions, they are including both your substitution effect and income effect. Okay, Both of them are being taken care of in this. Okay, that is both substitution effect and income effect. Now, in case of net substitutes definition, okay, xi and xj they're being said to be net substitute if del xi by del pj is greater than 0, and they are said to be net complements if del xi by del pj is less than 0, with one condition, that utility is kept constant. Okay, so it means that you're actually looking only at substitution effect. Okay, and we know this, that substitution effect unambiguously have the same sign, which is negative. Okay, in all cases. So now here you will not have a problem. Okay, in case if you are trying to see at when the utility is being kept constant, then you can probably say with high level of certainty whether the goods are net substitutes or net complements. Okay, so this definition will always hold. It will not have a problem. That is, the two goods are net substitutes when xi and xj are such where your del xi by del pj is greater than 0, keeping utility constant, and xi and xj are net complements if del xi by del pj is less than 0, keeping utility constant. Okay, so we're looking only at the substitution terms to determine whether the two goods are substitutes or complements. Now, this definition is intuitively appealing, and because it looks only at the shape of the indifference curve, and theoretically desirable because it is unambiguous. I mean, there is no level of ambiguity in this. Okay, thanks.